Exercise 1.2 real numbers. We have to prove first sum. Prove that root 5 is irrational. So for that, let us assume to the contrary that root 5 is a rational number. We can write root 5 equal to a by b, where a and b are integers and b not equal to 0. Suppose a and b have a common factor other than 1, then we can divide by the common factors and assume that a and b are co-prime. So b root 5 equal to a. We squaring on both sides, we get b square into root 5 square equal to a square, which is nothing but 5b square equal to a square. Therefore 5 divides a square. As per the theorem, what is the theorem? Let p be a prime number. If p divides a square, then p divides a, where a is a prime integer. It follows that 5 divides a. So we can write a equal to 5c for some integer c. Substituting for a in 5b square equal to a square, that is, we have to substitute a square as 5c square. So 5 square c square. So we get 5b square equal to 25c square, which is nothing but b square equal to 5c square. This means 5 divides b square. As per the above theorem, 5 divides b. Therefore a and b have at least 5 as the common factor. This contradicts the fact that a and b have no common factor other than 1. This contradiction arises because of our incorrect assumption that root 5 is rational. So we conclude that root 5 is irrational number. Second question, 3 plus 2 root 5 is irrational. We need to prove. Let us assume to the contrary that 3 plus 2 root 5 is rational. That is, we can find the co-prime a and b such that 3 plus 2 root 5 equal to a divided by b. These two are co-prime numbers, b not equal to 0. By realigning, we get 3 minus a by b equal to 2 root 5. By taking LCM, we get 3b minus a divided by b equal to 2 root 5. So we move 2 to the left hand side, we get 3b minus a divided by 2b equal to root 5. Since 3, 2, a, b are integers, this equation 3b minus a divided by 2b is rational, and we get root 5 also rational. So this contradicts the fact that root 5 is irrational. This contradiction has arisen because of our incorrect assumption that 3 plus 2 root 5 is rational. So we conclude that 3 plus 2 root 5 is irrational. Third question, prove that the following are irrationals. First subdivision, 1 divided by root 2. Let us assume to the contrary that 1 divided by root 2 is a rational. That is, we can find the co-prime a and b not equal to 0 such that 1 divided by root 2 equal to a by b. By aligning, we get b divided by a equal to root 2. Since b and a are integers, b divided by a is a rational number, and also root 2 is also a rational. But this contradicts the fact that root 2 is irrational. This contradiction arises because of our incorrect assumption that 1 divided by root 2 is rational. So we conclude that 1 divided by root 2 is irrational. Second subdivision, 7 root 5. Let us assume to the contrary that 7 root 5 is rational. 7 root 5 can be written in the form of a divided by b, that is a and b are co-prime numbers where b not equal to 0. So keep root 5 in the left hand side, we get root 5 equal to a divided by 7b. Since 7a and b are integers, a divided by 7b is rational, so that root 5 is rational. But this contradicts the fact that root 5 is irrational. This contradiction arises because of our incorrect assumption that 7 root 5 is rational. So we conclude that 7 root 5 is irrational. Next sum, 6 plus root 2. Let us assume to the contrary that 6 plus root 2 is rational. That is, we can find the co-prime a and b not equal to 0. That is 6 plus root 2 equal to a divided by b. By rearranging, we get root 2 equal to a by b minus 6. Since 6, a and b are integers, we get a by b minus 6 is rational, so that root 2 also rational. But this contradicts the fact that root 2 is irrational. This contradiction arises because of our incorrect assumption 6 plus root 2 is rational. So we conclude that 6 plus root 2 is irrational.